Hello, everyone. So this is going to be our first chapter. What is psychology? Chapter 1. So you can write down the title. We're going to talk about what psychology is and some of the pieces around it. And we'll split this up over a few days, but here it is. So first, psychology. Let's just talk about kind of what it is. Now, psychology connects behavior with mental processes. So it's kind of the way our brain works and what we think, and then what that makes us do and how we do those things. Now, it's a science, and to be a science, you have to use empirical data. So you have to be able to use that empirical evidence to study how those processes affect physical and mental states, right? So we need data. We need to know scientifically that this works and that what we're studying is true and real and can be applied no matter what. So this is what kind of separates psychology from pseudoscience, like astrology. Astrology is, you were born in May, you're a Taurus, and so today you're going to have a great day, or your personality's like this, right? There's no data to back that up, right? That people's personalities are based on their astrological signs. There's no proof of that. So that's not a science. Another one is phrenology. And I put up there because I think it's interesting. Before psychology even was a thing, there was this idea of phrenology that each part of your brain has a certain trait. And so you could tell what traits you have based on bumps on your head, right? No one's head is perfectly smooth. So where are the bumps on your head? Oh, well, it's by the thieving traits. You must be a thief. And that's how they could tell, right? The problem is, once again, there's no data to back this up. Sometimes someone with a thieving trait didn't steal things. Oh, well, they have a bump in the side that makes them very saint-like. So they're not going to steal. That's going to win out. It doesn't work like that, right? So these minds, these behaviors, it's false, and that's the case. Now, Wilhelm Wundt is the father of psychology. He was kind of the first one in the late 19th century to study physical response versus perception. So he would shine a bright light in your face and watch you as you physically have a reaction to that light, right? And almost instantly, you're going to have a physical reaction to that light. And then he would ask, how did you perceive that light? And most people would say it's really bright. And that's what everyone would say. So he said, okay, that's how this works. That there is a physical reaction followed by the perception of that stimuli that is given. And so, for example, if I told half the class to raise their hand whenever they saw my hand move, and I told the other half, raise your hand when you can read how many fingers I'm holding up, I would start to raise my fingers. The first half is going to all shoot their hand up. That's the physical response immediately. That's what's going to happen. And then after a little bit, the other side of the classroom is going to be able to read, oh, you held 2 fingers up, I'll raise my hand. That's the perception. It kind of lags behind. Now, the thought was that William Wundt thought that everyone's physical response to perception was the same. We know that's not true. Some people may have thought that light wasn't very bright. So that's not true, but it was a start to this. And that kind of leads into the nature versus nurture debate within psychology. Basically, is who we are and our traits, are they nature? Are they something that we're born with and our genetics and our DNA? Or is it nurture? Is it our environment, our upbringing, our experiences, our childhood? Is that what determines who we are? So there are different schools of thought with this. We have kind of functionalism that argued more for nature, which was Darwin's theory of evolution, that our past ancestors learned things and gave that to us. Or someone like Sigmund Freud, who his psychoanalysis argued more for nurture, that people's experiences made them feel certain things or have mental illness, and he tried to cure that with psychoanalysis, talking out those problems. In reality, psychology is both. There are parts that are nature, parts that are nurture, parts that are both. So let's move on to slide number 2. The theoretical approaches. So these are the 5 theoretical approaches. I'll go over very quickly. The biological approach to perspective to psychology looks at physical events that produce those perceptions. It goes back to kind of that Wilhelm Wundt structuralism argument, right? So we have these physical events that produce perceptions, memories. When something happens to you, there is a biological production. So this is linked to evolutionary psychology. Think of like hormones. Think of testosterone. Right? If you have a lot of testosterone, that it could lead to more anger. With steroids, that's the biological perspective. Here's a chemical that is physically going to produce perceptions, going to physically produce memories, going to physically produce emotion. The learning perspective, number 2, is used by behaviorists, and that kind of tells how the environment affects your actions. So they focus on what can be measured. Do you have a bad temper? That's something that we can kind of measure. And you can know if you get angry very easily. So they would look at, if you have a bad temper, they would look at what's in your environment that makes that happen, and can we change it? Pretty simple. We'll focus more on this later, but they'll also use rewards and punishments. And when you get angry, if I hit you on the top of your head every time you get angry, eventually you're not going to want to get hit, so you're not going to get angry. So that's classical conditioning. We'll get to that later, but that's learning perspective. Number 3, the cognitive perspective focuses on mental perspectives, how people reason, how people solve problems. We grade this with something like the IQ test, something like the SAT, standardized testing, is a lot of the cognitive perspective about how you reasoning and solve problems and try to make that uniform. Number 4, the sociocultural perspective is for kind of social and cultural forces outside the individual. How does our society or our culture affect what we do? How are family members treated in our culture? How are women treated versus how are men treated? What are these gender roles? That's something that's cultural usually. So this gives kind of more context for people's actions. And 5, the psychodynamic perspective deals with the unconscious and the subconscious. So it's kind of unique from the others, but it says that, hey, there's something underneath that you don't know about that is causing you to do things or think things. So think of the power of fear, the power of sex. Those type of kind of subconscious feelings that people have may cause you to do things or feel certain ways, perform actions or behave in a certain way that you may not know. So something else we'll get into. We'll get into these much more later in the course, but there you go. Moving on to slide 3, what psychologists do. So, who are psychologists? What do they do? And I'll cover some things, but there's kind of 2 types of focus for psychologists. One is the basic psychology versus applied psychology. Basic asks why we do things, and then applied asks how to use that knowledge to do things. So, for example, basic would ask, how does peer pressure influence people's attitudes and behaviors? So we're kind of asking the why. How does peer pressure? Why does peer pressure affect people's attitudes and behaviors? Applied would try to apply that information. So they would ask, how can we use that knowledge about peer pressure to reduce vaping in high school? So if we know that peer pressure influences people's behavior, how can we use that to reduce peer pressure and thus reduce vaping because people vape because of peer pressure, perhaps? I don't know if it's true, but that's an example. So that's basic versus applied. You need the basic to get to the applied. And they use a scientific method, hopefully something you've learned about in science, to form a hypothesis, to form an educated guess of what you think is the case, right? When we ask that, how does peer pressure influence people's attitudes and behaviors? We're going to guess, I think peer pressure does influence people to follow the crowd. And so we're going to have to create operational definitions of certain things, because in psychology, not everything is specified. You don't always know what things are. So, for example, when I say, if we're going to do a study about anxiety, what is anxiety? That first we have to have a definition of what that is. How do you measure it? What is fear? How do we measure fear? You have to come up with ways to do that. So that's something we'll talk about when we talk about studies. We'll explore that later. There are a lot of different types of psychologists. Maybe even in school, we have a school psychologist. You may have experienced counseling psychologists. There are clinical psychologists that diagnose, treat, study psychological and emotional problems, and psychotherapists that do psychotherapy. I talked about that with Sigmund Freud. That's the person sitting on the couch talking about their problems, right? That'd be a psychotherapist. A psychoanalyst is one who practices psychoanalysis therapy. So kind of different steps to this. So, these might be people you run into from time to time. A psychiatrist is a doctor who diagnoses, treats mental disorders, oftentimes with medication. So just different things. Is it therapy and trying to improve, or just being kind of analyzed? Different ways. So different psychologists do different things. Let's move on to slide number 4. I'm going to go with scientific thinking. And so scientific thinking, we want to keep away from assumptions and biases when we're looking at psychology. We have to stay away from that. And in our daily lives, you want to stay away from that. We may assume things without true evidence, but it's unlikely to be true. And this happens for psychologists as well. After creating definitions and they're gathering data, they have to follow what's called the principle of falsifiability. They have to understand their hypothesis could be disproven with contrary evidence, and they also have to allow for what could not happen for the hypothesis to be incorrect. So you try to bypass the emotional reasoning for logical reasoning. Let me give you an example, because I think it's a lot of words, but you may not really understand what that means. So they have to predict not only what will happen, but what won't happen. So let's say we're going to study the assumption that misery loves company. Right? People who are miserable, whether maybe it's depression or anxiety, that they love being with, they love company, they love making other people miserable with them. So if we're going to study this, the hypothesis would suggest that most anxious or depressed people seek each other out, right? They're looking for people that also are miserable, quote unquote. But that would be disconfirmed if those people went off to sulk alone, or if anxiety and depression had no effect on their behavior in this case, which is likely the case. So you can't risk confirmation bias of twisting the data to fit the narrative that you want, just because you want that to be true. You want misery loves company to be true. It could be disproven. So you don't want to use anecdotal evidence. I've heard that term before, because that's also problematic. So, if your Aunt Dottie has anxiety and depression, and so do all her friends, that doesn't mean that misery loves company, because Aunt Dottie loves company. And so, that's only one personal experience or example. So you have to consider other studies. You have to consider bigger numbers. You need a good sample size. We'll talk all about that. But just know you don't want to use personal experiences. Well, I've never seen this happen. Well, that doesn't mean it doesn't happen, right? You're one person. So you need to be open to those things. All right, let's move on to slide 5. So different types of studies that we're going to take a look at. So a case study is a study that can provide anecdotal evidence, but also give a deeper insight to specific cases. So case studies generally aren't used as kind of a be-all, end-all, but what we're going to do is we're going to look at someone specifically with the case. If we're studying bipolar disorder, you might have a case study of someone with severe bipolar disorder, and it might give you some insight on the actions and possibilities, but once again, it's only one person. So that's the downside. Observational studies are to try to find out how people act in nature, in certain situations, maybe in a laboratory setting. But so we want to observe people act naturally, right? And that can be tough. That can be tough because if you're being watched, if you're in a study, then you may act differently. So let's say I gave everyone a very hard test, and we wanted to see if you were cheating. And so I put a person in the room to observe you take this hard test. And would you cheat? Probably not. What if I had no one in the room, just you? Maybe you would. You'd probably be more likely, right? But so if we want to get actual results, we can't have the scientist sitting in the room with you watching you. So that can be a barrier as well. That can change things. Psychological tests use data to get results. So I think aptitude tests, personality tests, if you've ever taken one of those, some are viable, some are not, but there are some that are, and that uses data. Standardized testing comes from this, to establish a baseline and get reliable results. That's why we have like the Keystone exams. That's a standardized test that is kind of built to be standardized for everyone and have those reliable, valid results. IQ tests, the SAT, those type of things are all involved in that. Surveys can be great way to get information, but you have to be sure you get a true representative group. So, if I'm going to ask people a question and poll them, that's great, and that might be good information, but I have to make sure I have a true representative group to make sure this is accurate. People actually think this. So, like if I ask the question, does money buy happiness? If I polled a bunch of millionaires, they may have a different name. They may say no. Most of them might say no. But if I polled a lot of people making under $20,000 a year, most of them might say yes. So if I really, I could be a bad scientist and skew my results if I wanted to by picking my sample, picking the group of people. So you want to combine those groups as well as other groups to get a full sample. And when you get people to do these studies, that can be an issue too. It's called volunteer bias. If you say, hey, I want to give this poll, are you willing to take it? If you only take the people that say yes, which is all you can really do, you have to be careful. The people saying yes are part of one group or another. So you want to, you also have to want to phrase questions on the survey to get real answers. Sometimes people can lie. If I ask you, have you ever stolen anything? You'll probably say no, even if you have. It's easy. But if I say, how many times have you stolen something? Well, that's probably a more reliable result because now I'm kind of assuming that you have. So you don't have to say zero. And you say, two or three, right? So that you have to pose the questions in the right way as well. Let's move on to slide 6, correlational studies. So, so correlational studies is something we're going to really develop here and talk about. That when we study something and we see that there are two different variables that are correlated, we can see maybe that there's a connection between them, perhaps. So let's ask this question. This is kind of the question I'm going to pose through these next few slides. Does a student's GPA drop the more hours a week they play video games? So does their GPA drop if they play more video games a week? How can we find out? We can do a correlational study, right? We can see if those two things are correlated. So correlation is about a relationship between two variables. In this case on the slide, we have a positive correlation, which is the taller people are, the more people weigh. And that's a positive correlation. Generally true. Not 100%, right? But generally true. We'll come back to that. The same with IQ scores and grades. Generally, people with higher IQs have better grades in school. That's a positive correlation. There it is, positive correlation. Now, this is a negative correlation, right? So if you have, if they're kind of opposite, then it's a negative. So the age of a car, the higher the age, the lower the price, right? The older a car is, the lower the price is going to be. That's a negative correlation. Those two variables going opposite directions. So you can kind of see the arrows. Here's positive, both going up, or both going down would be positive, and then negative would be that they're opposite of each other. Now, this is slide 8. Some variables have no correlation at all, right? So like IQ and shoe size, no correlation. Some people with higher IQs have big feet, some have small feet. Some with lower IQs have big feet, some have small feet. It's not correlated at all. So that's that can happen too. There can be no correlation. And we kind of gauge how strong a correlation is by the coefficient of correlation. It's like +1 is the strongest positive, -1, strongest negative, and it goes in between there. If you're at 0, there's not much correlation at all. So we'll talk more about that later. Don't worry too much about it, but that's it. So let's go to our example about GPA. Is your GPA drop if you play more video games a week, more hours of it? We might find that the more hours a week a student spends playing video games has a negative correlation with GPA. So as the hours go up, the GPA goes down. Does that mean that one causes the other? Not necessarily, right? Correlation does not equal causation. Just because they're connected, they're correlated, doesn't mean they cause each other. So do people with lower GPAs just like video games? Maybe more hours playing does mean less time studying. So we don't know. It could go either way. Maybe they don't cause each other, but they're just correlated in some way. So that's the case. Here's a positive correlation, right? Wife's age, husband's age are positively correlated. Generally, when a husband's older, wife's older. Doesn't always happen, right? Some of those, you see a couple dots there that aren't perfectly in line, but kind of follows that. Here's a negative correlation. The weight of a person and the kilometers run per week. Generally, people that weigh less will run more. Not perfect, but it's a negative correlation. Now, correlation doesn't always equal causation, right? So here is some correlations when we look at the charts that match up with each other, but they're not caused by each other. We see the number of people who drowned by falling into a pool correlates with the films that Nicolas Cage appeared in per year. Now, does that mean that every time someone drowns in a pool, and Nicolas Cage says, "Hey, I got to do another movie," or every time he does a movie, someone drowns, he's causing that? No. It's another example. The letters in winning words of the National Spelling Bee correlates with the number of people killed by venomous spiders. So every time a spider kills someone, the Scripps National Spelling Bee says, "Let's add a letter to the last word," or the longer the word, the spiders start coming out. No, right? So that has a 0.8 correlation. That's pretty high, but that doesn't mean that they cause each other, right? So be careful, with that. So here's kind of how all of them look: strong positive, weak positive, strong negative. You don't have to write all this, but you can kind of take a look and go back to this if you need it, right? No correlation could be all over the map. That can happen as well. So experiments. We have to treat any experiment done ethically so that no harm comes to participants. So if we have an experiment, we have to make sure there's no physical harm or no mental harm, right? So we can't always, sometimes experimentation can be off limits. That's why you generally have researchers use rats or mice if there could be some type of danger. Even if not, it's a good place to start. But if we have to actually have something where people could get hurt, you can't do that study. Now, each study has to have an independent and a dependent variable, right? That's kind of the two sides. Everything stays the same in the study except the independent variable. That's what changes. So we will, and I'll give you an example of all this in a second. We must also have a control group where everything's normal, everything's fine, an experimental group where we adjust that independent variable. And these groups have to be randomly assigned. So we can't place people into the groups that we want, right? Or it could skew the results. Even something that you feel like is quote unquote random, if like what we're doing in school, right? That the A through L's are in class. If that's my control group, then I say, well, the second half of the week, the M through Z's are going to be my experimental group. That's not random, right? So that will not work. And then the researcher knowing who is in what group could also lead to bias. So what you ideally want is what's called a double-blind study, where the researcher doesn't even know which group is experimental, which group is control. In a single-blind study, then the experimenter knows, but the people don't know. If the people know, then you're in trouble. So, for example, let's say we're researching a new drug to combat depression. The control group would be given what's called a placebo. That is a sugar pill disguised as the drug. And then the experimental group would get the actual drug, so you can compare the results. So both groups think they're getting the drug. Ideally, the researchers won't even know which is the placebo and which is real. Another example. Let me give you another example. So let's say our hypothesis is that cell phones impair driving ability. We want to test that. Now, if we want to test that, and I have people on the road texting while they're driving, that's dangerous. That's an experiment that can't happen. That could cause physical harm, right? They could hit someone, they could die. So we can't do that. But we're going to have a control group that's not texting while driving. And then we'll have an experimental group that is texting while driving. And we'll have to simulate the driving. Right? We'll have to have a simulated course, maybe some type of kind of video game-esque course to drive in. So we don't actually send them out on the road because that's unethical. We want to simulate. So, we would gauge the number of collisions over this course. They drive the exact same course, the exact same car. One group is texting, and that's our experimental, and one group is not. That's our control, and we compare those results. So the last slide, slide 10, evaluating findings. We'll take that information and we turn it into descriptive statistics to help organize it into mean So median, mode, things hopefully we've had in math class. And inference statistics let us make inferences on those hypotheses. Basically, can we get viable information from this? Can we learn that texting while driving is dangerous with these? We have to look at the stats. We have to see, did that group all have a higher number of collisions? What about the couple people that didn't? What about the couple people that had less than those that were in texting? How can we kind of organize this to understand and figure that out? So that's where standard deviation comes into play. We should look at our standard deviation, which is kind of how events deviate from the mean, from the middle. So most people are going to do the same thing. But there's going to be some outliers. How many do we have? How far out is it? If we have a lot of outliers, maybe there is no correlation. Maybe that's that graph we looked back with all the dots all over the place. So experiments have to have a significant impact. We can test how significant they are. Ideally, eventually, you'll have tests to be replicated over that. That's what kind of meta-analysis is, right? Studies over multiple studies to see if that data is consistent, or cross-sectionally. Maybe we'll test a group of people who are over 50, and you'll do a test, in the group that's under 21, and maybe that's different. So we need to have cross-sectional studies of different groups to make sure that we are accounting for any possibility of other variables coming into play. So it's a lot of basic information, but this is kind of the basis for this course and first chapter.